Hi everyone, my name is Ben Lafreniere, and I'll be presenting our paper, Authoring LLM-Based Assistance for Real-World Contexts and Tasks. This was a project by my former intern Hai Dang at Reality Labs Research in Toronto, with the co-authors that you see here. And this project came out of a question. How can we enable AI assistance for real-world tasks? LLM-based chat assistants are a powerful tool for helping people with personal tasks, but they're at their most useful when they're working with digital information while sitting at a computer. Much less so if, say, you're standing in the aisle of a grocery store. So we wanted to explore what new interfaces and interaction metaphors are needed to enable users to ask for and get assistance with real-world tasks. And so with that as motivation, we conducted a formative study to understand real-world scenarios for AI assistance. We introduced the concept of contextually-driven prompts, or CDPs, that provide a way to enable LLM-based assistance for real-world tasks. We built World Prompter, a system to test this concept, and we conducted an evaluation and authoring study that gives some new insights into how users go about requesting and refining this kind of AI assistance. So I'm going to focus on the last three of these in this talk. All right, let's dive in. So in this work, we propose the concept of contextually-driven prompts, CDPs, which are structured natural language prompts that express a user's goal and how an AI assistant should respond to real-world context to assist with that goal. So for example, the user might instruct the system, when I'm in the grocery store, show me the items from my grocery list for the aisle that I'm currently in, and get a CDP that looks like this. So there's structure in that it's split this instruction into a trigger and action, but both the trigger and action are expressed in natural language. And so CDPs extend this existing concept of trigger action programs, but there's a few important differences. Whereas trigger action programs are thin wrappers over deterministic code, CDPs are natural language instructions to language-based AI models. As well, instead of a fixed set of triggers and actions that you have in trigger action programs, CDPs are open set in that they can sense context and provide assistance at varying levels of abstraction. And while trigger action programs are executed deterministically, CDPs are interpreted at runtime by LLMs or other language-based models. And I'll show an example of this with a vision language model later in the talk. So as an example of the added flexibility of CDPs, you could have something like this. When I'm about to leave the house, remind me to bring my keys. But it's also acceptable to have something like this. When I'm about to leave the house, make sure I don't forget anything important. The action statement here is more abstract, and then it's up to the LLM-based AI system to handle that execution. And likewise, the trigger could be more broad or narrow as well. So this added flexibility raises some new research questions. In particular, how can we assist users with finding the right level of assistance for their goals? And second, what strategies and practices do users adopt in conversational interactions when specifying and refining CDPs? To investigate these questions, we built a prototype system called World Prompter. So here's the interface to World Prompter. We implemented it as a mobile app prototype to quickly stand up the idea, but I'll note that the main interaction with the system is via voice, so it would be straightforward to translate to, say, smart glasses with a heads-up display. Okay. To start creating a CDP, the user can press a microphone button and speak a query to the system. And the query is automatically structured into a trigger and action, rephrasing it as needed. And then the system offers a set of suggestions for how to improve the CDP based on concepts that could be narrowed or broadened. And then from here, further iterations can be made by using additional voice queries to the system. We also implemented a testing interface to simulate execution of CDPs in hypothetical contexts. So the user can describe a custom context in natural language. For example, they could say, I have X, Y, and Z items on my grocery list. Alternately, or additionally, the user can take a picture using the device's camera. And the current context is maintained in natural language. And when updates are provided by the user, an updated action plan is produced, which describes the steps the system would take to execute the CDP. And this enabled us to assess CDPs without requiring the creation of a fully integrated system. So in the study I'll show next, participants used World Prompter to create and test CDPs for a range of personal tasks. But before I get to that, I want to say a little bit more about the image context updates, because it's kind of a cool aspect of the system and it illustrates some technical elements of our implementation. So when the user captures an image, the system prompts an LLM to consider the CDP and generate a question to be passed to a visual language model. We used the language model Lava. So in the grocery shopping example, this question might be, what aisle is the user currently in? So the VLM receives the image plus the question, and then it gives a textual reply. Like it could reply, the user's in the drink aisle, or the user's in the cheese aisle, or the user's in the bakery aisle. And then this response is passed back and used to update the context and generate the action plan. So in this case, it would appropriately filter the grocery list. So this example illustrates how CDP's natural language triggers and actions can be interpreted at runtime by different language-based AI models. Okay, I'll finish this talk by describing the evaluation and authoring study. So in this study, we wanted to test, 1, to what extent does World Prompter support users in authoring CDPs for their goals? 2, how do users approach creating CDPs in World Prompter? And 3, how do users perceive and interact with suggestions? So we conducted a 90-minute study. It was an in-person study, and participants were asked to brainstorm 3 to 5 use cases for CDPs, and then choose 1 or 2 of these use cases, and then spend the bulk of the time creating and testing their CDPs in the World Prompter system. You can check the paper for full details. Okay, what did we find? Well, to our first research question, assessments of World Prompter were generally positive. So this came through in the questionnaire results you can see here, as well as the feedback in the interviews. And I won't go through all of these, but I'll note that we had high agreement on CDPs for real-world activities are useful. The assistant helped with refining the CDP. The system understood the high-level goal, and satisfaction with the resulting CDP. I'll also note that feelings on the suggestions were a bit mixed, and I'll talk more about that in a couple of slides. To our second question, participants exhibited a range of different strategies for initiating CDP creation, including starting by stating a high-level goal, to brief narratives where they would kind of describe the situation they're in, to kind of implicitly suggest their need, to ad hoc queries where they would start with asking the system for suggestions of some ideas, to if-then statements, which are kind of more already structured in the trigger action format. And these are really interesting because you could imagine building in additional prompting or even fine-tuning to detect and support these different strategies. To our third question on the suggestions provided by the system, participants highlighted both positives and negatives to this feature. On the positive side, they expressed that the suggestions prompted reflection on how to improve their CDPs, which was the point of the suggestions, and provided cues about the system's capabilities, which wasn't something we built in explicitly, but it shows an opportunity there. On the negative side, at times they could find the suggestions to be overwhelming and sometimes inconsistent, which could cause confusion. In the current system, we always provided suggestions, and at times this could result in suggestions to narrow concept, followed by a suggestion to broaden the same concept. And so these results really suggest that we need more sophisticated approaches for generating and deciding when to make suggestions. Finally, we observed a number of different strategies for how participants used conversational interactions to incorporate the suggestions of the system. So some of these included positional reference, like saying include suggestion 3, a referencing multiple, such as include suggestions 1 and 2, a reading aloud where they would just repeat back some of the text of the suggestion to apply, and one that we called editing reference, which was something where they would repeat back kind of parts of suggestions, but while they did so, they would kind of elaborate, remix, or customize them in the process. And again, I think these are interesting observations because you could imagine building support for these different strategies into a system. In conclusion, in this paper, we've introduced the concept of contextually-driven prompts as a new means of requesting and receiving AI assistance with real-world tasks. We presented the World Prompter system that demonstrates a CDP authoring interface, and we reported novel study results around authoring of AI assistance for real-world tasks. With that, I'll conclude. Thank you so much for watching.